REST APIs allow your game to send requests that can contain any kind of information to a remote server. The remote server can then either reply with the information that you requested or make changes on its end that you requested it to make. Now, in this two-part series, we'll show you how to set up a REST server and connect it to MongoDB so that it can store and update changes in the database. And then in part 2, we'll talk about how you can then establish a connection between your Unity game and this server so that you can give your players a better overall experience. Let's get started. Now, the server is meant to be cross-platform, but in this case, I'm going to assume you're building this on a Windows machine. So to get started, we need Node.js. Head over to nodejs.org and install whichever one of these two versions you prefer. Next, we'll need MongoDB. Now, finding the exact version of MongoDB that you need can be a little bit tricky, but for us, we need the Community Edition. So to find that, we'll head over to Products, and under the Community Edition, you can find the Community Server, and I'll just go ahead and click on that. Now in here, there's a version for Windows. If we just scroll down, we'll find the option to select a package, and then the platform here says Windows. It's giving us an MSI, and you could just hit download to download this MSI. Now, MongoDB is a massive download, so while it finishes, we'll start our work. What you need to do here is create a new folder, then head over to the top here and type cmd to open this folder in a new terminal. We'll then hit npm init, and this creates a new NPM project inside of our folder. Now, there's no need to enter any of these default settings, so I'll just hit enter a bunch of times so that it sets us up with the default project. And then what you should see in your project folder now is this package.json. Go ahead and open this entire folder in your favorite IDE now. For me, it's Visual Studio. And after a while, Visual Studio is opened up and ready to go. In case this is the screen that you have, you might be a little bit confused. You want to make sure that you can view the Solution Explorer so that you have a list of all the files in your project. And all we need is this package.json file over here. So I double click it to go ahead and open it up. And what we're going to do now is we're going to edit this file and add some of the dependencies for our project. Now, we could sit here and type all the dependencies we need one by one, but to make it really easy, I've shared the link to my Discord in the description, and it's a straight link that takes you to this resources section on my Discord. This is where I share all the resources for all the tutorials that I make. There's a particular resource here that's meant for this particular tutorial over here, and if you just click this, one of the first posts that you should find has the modified JSON file that has all our dependencies listed right here. So these are all the dependencies we'll need. Now I'll just highlight everything in this file over here, and I'll just copy it, and I'll head back over to Visual Studio and I'll select everything and just paste it here. So you can see it just selected everything and it replaced it. Now again, in case you named your project something different, you might want to change this name, but most importantly, we want to focus on these dependencies here. I'll go through one by one just to explain sort of what they do. So Express is the main JSON package that we're going to be using here, and it's going to be running our entire website. The Express validator here helps us make sure that the requests that we want match a specific format. So for instance, if you had somebody trying to set a password on their account, you'd want to make sure that that password has a minimum length. That's what the Express validator helps us do over here. The JSON stringify, this is very important for breaking down requests that come over the internet. Sometimes they're in a string format and you just want to convert them to JSON objects. Mongoose helps us interact with our MongoDB, which we're just about to set up, and the body parser here takes care of the body of the requests that we get from our Unity API. Now in here we have a dev dependency. This is NodeMon. This is going to help us run our web server, and it's going to automatically rerun it when we make a change. Now that we have a clear understanding of the package.json file over here, I'm going to hit Ctrl S to save it. And if we head back into our terminal here where we created the project earlier, what we should be able to do is run npm install, and that will start installing all these packages over here. So you do want to give it a bit of time. These are quite a few packages, and as we give it that time, we can then go ahead and start to install MongoDB on our machine. So I assume by this time your MongoDB is done downloading. I'll go ahead and hit next. The installer here is really straightforward. You just need to do a complete installation, and it goes ahead and asks you a few questions over here. You really just need the default answers. In this case, you don't need to worry too much about what it's asking for here. So just hit next. I'll go ahead and hit install, and it goes ahead and starts installing. So we have both MongoDB installing over there, And in this case, you can see our npm is actually done running, so we're just waiting for MongoDB at this point. All right, so once MongoDB is done installing, you should get a window like this. This is the MongoDB campus. It's really useful for managing the databases on your machine, but we're not going to be using it just yet. Another tool that you need to have installed is Postman. So to do that, open any web browser and head over to postman.com. And there's a lot of prompts to create an account here, but we really don't need to do that. All you need to do is find the download buttons for whichever operating system you're using. So in my case, they're down here. There's the desktop apps for Windows, Mac, or Linux, and I'll just download the Windows one. Once you download it, go ahead and install it. The process is really straightforward. And once you're done installing it, you should have Postman installed, and the window looks something like this. So once you have it, you just want to keep it tucked away for the minute, because we're going to start to set up our default application inside of our Node.js app. Now again, to make this really easy, I've left the complete and final index.js file inside my Discord under the resources section. In the REST API and MongoDB Unity tutorial section, you will find the final index.js available for download here in case you just want to use it straight away, and you can just watch the tutorial just to understand how things are working. In any case though, let's start adding the minimal functionality here for us to be able to run our application. And the first thing we need is to initialize the Express application. So that's really easy to do. Here we just create a new variable Express, and it requires the Express node module that we installed a while ago. We also need a body parser because we're going to be dealing with JSON objects that are stored inside of the bodies of these web requests. We need a body parser in here, and then we can go ahead and initialize our application. So this just initializes our Express application. Now the following lines are only important because we want to have full functionality for the JSON functionality that we're using. So I'll just make sure to write this here. So this is JSON functionality. Now sometimes including JSON things within web request bodies can turn out to be a little bit complicated. This just helps us so that we know exactly how we're dealing with these JSON files. This particular line here though allows us to post a website, like a static website, inside of a folder called public. Right now that folder doesn't exist, and luckily Express does not require it. But in case the folder did exist, you could put an html.index file in there, and that would display a static website. Now that we're done with that, what we want to do is we want to initialize the routes for our application. Now by routes, technically what's going to be happening is people will be able to access our application using an IP address. So in case it's 192.168.100.1, and they can slash this with something like API slash confirm functionality. And this is how they're going to be accessing certain things within our API. So this will be the URL for index of an API. So to do that in Express, we need to use the routes, and using routes is really, really easy. I'm just going to add the line that does that over here. So all this is saying is whenever somebody visits our domain and slashes it with the API, you can refer to a folder called routes, in which there will be a file called API that will contain how you should handle those particular requests. So to allow this to work straight away, because for now our application will not compile, we just want to create a new folder in the solution. Here I already have a folder called routes. I'll just right click this and I'll add a new file, and I'll call this api.js. So this api.js directly corresponds to the /API that we have over here. There's no need for the JS in the actual code. Now that's just about it, but we do need to be able to handle errors from time to time. So I've added an extra piece of error handling middleware here. So this allows us to send back responses that will tell the person who has requested our message what the error was and exactly what the error message is. And finally, we need to actually listen for requests. So I'll add this final part over here. This just tells the Express application to listen and set the port as port 4000, and this is the function that will run when we start listening. So this will, in the console, this will read ready to go straight away. Now, because we are using the routes API here, we need to export a minimum functional module from that file. So to do that, let's go ahead and open up the file. and start adding the minimum module that we need here in order to be able to use this as a route. So once again, we'll go ahead and import Express over here, but we'll import it as well as the routing functionality for Express, so these two sort of work together. And then what we want to do is want to say at the end here, we want to say module.export is equal to router. So now the application can compile because we have exported a router here that is getting used over here. So without this export statement here, normally the application would not be able to compile. So well then, now we're ready to test our application. If you just head over to the folder that has the application, you can open the command prompt from the top here, and we're going to use npx here, and we're going to type nodemon. So this nodemon command here will immediately run our api.js file, and it should give us some feedback on how it's running. So if I hit enter, you can see it says here, it says ready to go. So that means that this particular console.log line here is running, and we are now listening on port 4000 for requests that are sent to this particular application. However, inside of our api.js, we don't yet have any replies, so the application cannot yet reply to any requests that are sent to it. So what we're going to add to do that is this particular block of code over here. And what this is doing is it's using the router to provide an additional path. So here we talked about having our localhost /API. Now on top of the /API, you then have /confirm active. And this is the function that will run when this particular API is visited. So here you can see we have a request. This is what contains the requests from the person who's sending the request. So from your Unity game, we then have a response that's used to respond to the request. And then we have the next here, which is used to handle errors using this particular code over here. Normally at the end here, you'd add something to catch an error in case there was an error. But in this case, there really can't be an error because all we're doing is we're sending a response that says the server is active. So how do we query this? What we're going to do is we're going to open Postman, which is the application we talked about installing earlier. And we're going to start by constructing our link here. So I already have a few links here, but technically what you want to do is you want to do HTTP, and you want to use /. Now this is being hosted on our local host. Normally you type in whatever IP address you're using. And I'll do the /, here to specify what port we're querying. So this is 4000, not 5000. And now I use /API /confirm active here to run this particular confirmation request here. So this is going to run this function over here, and this function will reply with this message. So just to confirm that this is working, I'll go ahead and hit send, and we have an error. So I did some debugging, and it turns out there was really not much to do. The reason I got the error was just because I hadn't saved the api.js file. Once I saved that, the application goes ahead and refreshes here in nodemon, and inside of Postman you can see that now when we send this request, we get a reply that says the server is active. So we've done one particular request, and this helps us now confirm that our server is running. But usually we have more than just the type of request that we've used. You can see here in Postman we're using a GET request. This list here shows the rest of the requests that are normally available in these sorts of REST APIs. Now, not every REST API has all of these methods, and you can see here there's actually an option to type a new method. And for our particular application, we're only going to be using router.get and router.post. So these are the two applications, these are the two methods we're going to be using. Router.get is used when you're trying to retrieve information, and router.post is used when you're trying to set information. But now that we have the minimum application working, let's go ahead and start to integrate our MongoDB into it and show how we can get information from the database and also post information into the database. Alright, so now we're going to use a post request to add information to our database. Before we can actually start to do that though, we need to do two things. First, we need to connect to the database, and then secondly, we need to create a schema that will define the structure for our characters. So to do that, we'll just remove this post line here because that will cause an error in our application if we try to run it before we have it set up. And then inside of index.js, we can start to import the libraries we need to work with Mongoose, which is what we use to write information to the database. So to do that, I'm just going to add this single line of code here, which just requires the Mongoose interface that we installed earlier. And then now we want to connect to our Mongoose database. So I'll do that around here before we use any of this JSON functionality. So just add this. Now, depending on what operating system you're running here, you might have issues with this IP address over here. So for some operating systems, this only works if it's set to localhost. On Linux, you might find situations where you need to set this to this digit over here. But regardless, if you're having a hard time connecting, you might want to look into the IP address that you're using over there. But once we're successfully connected, now we want to create a global promise that we can use while accessing Mongoose like this. There are a few additional lines of code here that I've just added to allow us to easily debug what's happening in case we're unable to connect. So this line over here will go ahead and log connected if we connect, and then if we fail to connect, we can log the error to our terminal. So now that we've got that set up, we can go ahead and try to run this code. So I'll open up a shell here and use npx nodemon to run this code. And you can see what we can see here is that we actually have a connection, so that's why it's logging connected. And now that that's set up, I will leave nodemon running in the background, and we can start to set up the structure for our users. Now I'm going to do that inside of a new folder here called schemas, and in here you just want to add a new file, a new JavaScript file. I'll call this user underscore schema. And in here we can go ahead and define the data structure for our users. So in case you're unfamiliar with schemas, these just allow us to specify what data structure we're using inside of MongoDB. MongoDB is a NoSQL database, so you need to have some sort of description of this sort. So for this, I will import both Mongoose and Mongoose schema into our file here. And then this following code here just allows us to define a structure for our users. So you can see we're creating a new schema over here, and we're specifying a few data structures in here. So in here is where you specify what data you have here. So whatever information you want can actually be added here. So once we have that set up, we can go ahead and export this. And exporting it allows us to use it in an external file. So now back in our API.js here, we can now begin to make the final changes to be able to add a user. What I will do at the beginning here is I will import the user schema that we created in this file over here. Now that we have the schema, we can begin to write our post statement over here. So again, this looks very similar to the previous one. And all we're doing is we're specifying a path that will be used while adding this object to our database. And then we can get access to the information that's included in the request from the body. So to do that, normally what I like to do is get access to this information using separate set lines, so that in case the location of this information changes, all I need to do is change it up here. And then just for the sake of making sure that it's working, I will go ahead and log this information to the terminal as well. And then finally, now we're going to use the create statement inside of our schema. So this is quite a bit of code, but it's actually quite simple. So we imported our user schema at the top here. And what we're doing here is we're calling the user schema, and then we're calling the create function of that schema, and we're putting in the information in the body. Now, we're actually quite lucky that the body comes in a structure that is exactly what we need. So if you look up here at the schema file in here, we need a name and we need an email. Now, if you take a look at a sample request for the body here, so this is the sample that we're going to call, for instance, at the end of this tutorial, you can see that clearly it just enters the name and email of the user. So this is exactly the information that we need. And so we can pass the body straight into the create request here. But in case it wasn't like that, we could also create a new object in here that would look something like this. So you'd say body, so you'd say the name, and then you'd have access to the name here, and then the email, and then you'd also have access to the email. So both of these are exactly the same, but in this case for us it is more convenient to just directly pass the body in here. The then function is simply a promise that gets called after this object is created, and luckily it returns the user itself here. So we're just going to send back information about the user, and then we can catch any errors. So I already run this function here using some old sample data here, but then now I can create a new user. So for instance, user1, and then I will also have a new email, so user1@gmail.com. And if I set if I send this information, you can see the server replies with that user's information over here, and you can see it also logs the information over here. So that's it with adding new users. What we're going to do next is we're going to try to retrieve some information about those users. So now we know exactly how to add information to our database. What we need to be able to do next is to be able to get information from our database. Now this is super easy, and it will involve mainly just duplicating this function over here. So this is our post request from earlier, and just changing a few things about it. Now for starters, when we're actually getting information, we want to change this to a get request. Then we want to take a look at the URL, and we want to change this to a new URL. So for instance, this one for me will actually be get email. So this will be /API/users/get email. And then now we don't need access to the email anymore because our application is going to be asking for it. So here where we create variables, we'll only get the variable for the name. And perhaps we don't need to log stuff to the console anymore. This is really depending on your particular needs at this time. Next, we want to use Mongoose now to query for our users. So we're going to change a few things here. We're still going to use the user scheme over here, but now we're going to use one of its functions called find one. Now the find one takes in the definition for the type of object that you want to find. So this is basically a query. So it requires what information you're looking for. And to do this, you just pass in an object over here that contains an object definition and what data that object should have. So I'll show you what this looks like. Inside of our user schema here, we have a name and an email, so we can query for any one of these two parameters here. But in my case, I am going to be querying for the name in particular. So we start by specifying the name of the object you're querying for, and then what data it should have. So what this means basically is we're looking for an object, so we're looking for a user. We want to find one user whose name is equal to the name that we have been passed here. Now, whatever function you put into this then part here is the function that will be called when we find that user. So when we're done finding that user, we just want to make sure that we do actually have a user. So we're just going to call if user. And if we do have a user, we want to say response.sendback, and we're going to send back our response over here. So I am going to just say email for, and then I will add this information here. So email for the name that you passed in, is equal to, and I'm just putting together my string over here. So this is equal to the user that we have just received over here. I'll just make this bigger. This is equal to the user that we've just received over here dot email. And you can see my IDE is not detecting anything over there, but this email is exactly the email that was passed in here. Now, just in case we actually did not find any user, what we want to do is we want to send back a response, and we'll say response.send. That will be response.send email. It will be email for the name that you passed in. Yes, email for the name that you passed in does not exist on the database. So sometimes it depends on exactly how transparent you want to be with this sort of information. In some cases, you don't want your users to know this type of thing, but in this case, we're just learning how to build the technology. So this is pretty much all we need. So this is a post and get request. This is pretty much the fundamentals that you need to know to be able to work with APIs. And to test this out, I will open up my terminal, and in here I can just do npx nodemon, hit enter, and it says connected and ready to go. And if I open up my Postman here, you can see I already have it set up. So this is exactly how it's going to work. It goes to the localhost 4000/API/users/get email, and then I need to pass in which user I want to get. So right now I have a name for Namsanga, and once I send that, you can see it says email for Namsanga is this. I also had a user called user1, and once I send that, you can see it says email for that user is that. Now I don't have a user called random user, so if I try to get that, it just says email for random user doesn't exist, and I think I just forgot to put a space over here. So that's exactly how we deal with get requests. Alright, so that's just about it for building a general REST API. So in this case, we've been building a REST API with no consideration for Unity technology whatsoever. Now in the next video, which I'll have linked in the description below, we'll take a look at this REST API from the point of view in Unity. We'll take a look at how to construct a web request in Unity, and I'll show you a cool Unity tool called Unity Post, which is basically a replacement for Postman inside of Unity. So be sure to stick around for that, and I will catch you in the next video. Be sure to like the video and subscribe below, and join my Discord to ask any questions or get in personal touch with me. I will catch you in the next video. Peace out.